Next is active methylene compounds. Active methylene compounds. What are active methylene compounds? In active methylene compounds, a CH2 group is flanked between two electron withdrawing groups like CO group or CN group. The active methylene compounds are compounds in which a CH2 group is flanked between two electron withdrawing groups like CO group or CN group. Okay, example, look at here, example, C double bond O CH2, C double bond O C2H5. Okay, so O C2H5, CO CH2, CO OC2H5. Look at here. This CH2 group is in between two CO group. This CH2 group is in between this CO group and this CO group. Therefore, this hydrogen atom, that means these two hydrogen atoms are more acidic in nature due to the presence of two electron withdrawing groups. These hydrogen atoms are highly acidic in nature. Therefore, these hydrogen atoms can immediately react with a base. That is why these compounds are known as active methylene compounds. So in active methylene compounds, a CH2 group is flanked between two electron withdrawing groups like a CO group or CN group. In such compounds, these hydrogen atoms are highly acidic in nature. Therefore, this can immediately react with a base. That's why these compounds are known as active methylene compounds. The example for active methylene compound is one is this compound. This is diethyl malonate or malonic ester. Diethyl malonate or malonic ester. Another example is CH3, CO, CH2, CO, OC2H5. This is another example. Ethyl acetoacetate. What is this one? Ethyl acetoacetate. Ethyl acetoacetate or acetoacetic ester. Acetic ester. Okay, here also you can see that this CH2 group is flanked between two CO group, ethyl acetoacetate. One example is diethyl malonate. Another example, third example, look at it here. Third example for active methylene compound, CN, then CO, CH2, CO, OC2H5. Okay, and this one is ethyl cyanoacetate. Ethyl cyanoacetate. This is ethyl acetoacetate. This one is ethyl cyanoacetate or ethyl cyanoacetate or cyanoacetic ester. Another name is cyanoacetic ester. Okay, these are some examples for active methylene compounds. Okay, so active methylene compounds, CH2 group is flanked between electron. Sorry, here it is. This one is CN. No need of CN. This is CN. CH2, CO, OC2. Here also you can see that this CH2 group is flanked between two electron withdrawing groups. CO group is electron withdrawing group. Similarly, Cn also. Okay. So the CH2 group is flanked between two electron withdrawing groups like Cn or CH2. So this is ethyl cyanoacetate. Ethyl cyanoacetate. Okay. Now preparation of active methylene compounds. So we discuss the preparation of ethyl acetoacetate. Preparation of the active methylene compound ethyl acetoacetate. Preparation of ethyl acetoacetate. Ethyl acetoacetate or acetoacetic ester. Ethyl acetoacetate or acetoacetic ester. This is preparation of ethyl acetoacetate. The preparation, that is preparation method, is known as Claisen condensation. The method of preparation of ethyl acetoacetate is known as Claisen condensation. Claisen condensation, very important reaction. Claisen condensation. What do you mean by Claisen condensation? Claisen condensation is a self-condensation of ethyl acetate. Self-condensation of ethyl acetate in the presence of alcoholic sodium ethoxide, followed by hydrolysis, we get ethyl acetoacetate. So what is this one? This is condensation of ethyl acetate in the presence of sodium ethoxide C2H5ONa and ethanol C2H5OH, followed by hydrolysis H3O plus. This reaction is known as Claisen condensation. By Claisen condensation, we get ethyl acetoacetate. Now, mechanism of Claisen condensation, that's very important. Mechanism of, before that, Claisen condensation means what is that? Self-condensation of ethyl acetate. So, what do you mean by ethyl acetate? Look at here, CH3, CO, OC2H5. This is ethyl acetate. This is an ester. This is ethyl acetate, ester, acetate. Self-condensation means we need two molecules. This is first molecule of ethyl acetate. Now second molecule, again I am writing the second molecule. CH3 can be written as HCH2. Okay, this CH3 can be written as SCH2. This is second molecule. Then again same only CO, OC2H5, second molecule. Okay, in the presence of C2H5ONa and C2H5OH, then followed by hydrolysis. What will happen? Okay, look at it here. This is first molecule and this is second molecule. In the second molecule, CH3 is written as CH2H. Now look at it here, H and C2H5O. So what will be eliminated? Minus C2H5OH. Ethanol is minus C2H5OH and the rest is what we get? CH3, CO, then CH2, CO, C2H5, ethyl acetoacetate. This is our active methylene compound, ethyl acetoacetate. Now let us discuss the mechanism of Claisen condensation. Mechanism of Claisen condensation. Step 1. Formation of enolate ion. Okay, look at it here. Formation of enolate ion. Now our this reaction is taking place in the presence of sodium ethoxide, sodium C2H5ON. There is a very strong base. So what is happening? Look at it here. Formation of enolate ion. First, we are taking the first molecule of ethyl acetate, that is CH3, CO, OC2H5. This is the first molecule of ethyl acetate. This is first molecule acetate, and we have our base is C2H5ONa. That means C2H5O minus, and Na plus. This, so C2H5O minus is our base. This base removes acidic proton. This CH3 can be written as CH2H. CH2H. These hydrogen atoms are acidic in nature because this carbon is attached to electron withdrawing group CO group. Therefore, these hydrogen atoms are acidic in nature. Electron withdrawing group is here. So what will happen? Electron withdrawing group. Therefore, these protons can be easily removed. That means these hydrogen atoms are acidic in nature. Therefore, what will happen? This is our base, sodium ethoxide. Ethoxide ion removes a proton from this carbon, and this bond is shifting to carbon. Okay. So what we will get? We get what will be eliminated? Minus C2H5OH minus C2H5OH, and what we get? We get CH2, and since the bond is shifting to carbon, carbon is getting a pair of electron and a negative charge, and C double bond O C2H5. This is enolate ion. Enolate ion. This ion is known as enolate ion. Now look at here, this enolate ion can be stabilized by resonance. Okay, now this pair of electron will be shifted to here, and therefore what will happen? This bond, one of the double bonds, will be shifted to oxygen. So resonance stabilization of enolate ion, what will happen? CH2 double bond C, here will become O, and since the bond is shifting to oxygen, a pair of electron with a negative charge, O C2H5. This is the resonance stabilization. Resonance stabilization of enolate ion. This is very important. Stabilization of resonance stabilization of enolate ion. This is enolate ion. This enolate ion can be stabilized by resonance. This pair of electron will be shifted to here, therefore it will become a double bond. Then this pair of electron will be shifted to oxygen. So this is resonance stabilization of enolate ion. So this is the first step, formation of enolate ion. How the enolate ion is forming? Our base is sodium ethoxide, that is C2H5O minus, removes a proton from the first ethyl acetate molecule. Of course, we need two molecules of ethyl acetate. From the first molecule of ethyl acetate, what is removing? A proton is removed by our base, and we get enolate ion. Now step 2. Step 2. This enolate ion acts as a nucleophile. This is our enolate ion. Okay, only we need the enolate ion. This is our enolate ion. This enolate ion acts as a nucleophile, and will attack the CO group of the second ethyl acetate. That means, look at here. Here is our enolate ion, or we are writing the second ethyl acetate molecule. What is the second ethyl acetate? CH3CO O C2H5. This is our second molecule. First molecule is changed into enolate ion. That enolate ion is attacking at the second molecule. This is our second molecule of ethyl acetate. This ethyl acetate will be attacked by enolate ion. What is our enolate ion? CH2. Here is minus C double bond O C2H5. This is our enolate ion. This enolate ion will act as a nucleophile. Therefore, this negatively charged CH will attack on this carbon, partially positive charged carbon. So this will be shifted to here. So what we get? We get a structure like this. What is forming? CH3 CO minus, and I am writing this OC2H5 down. OC2H5 I am writing here, and this attacking group I am writing here. Then what is that? CH2 C double bond O C2H5. We get this structure. Okay. So this is attacking on this partially positively charged carbon. So what will happen? So it is CH2CO, C2H5, and at the same time this bond is shifting to oxygen. We get a structure like this. Okay. Now in step 3, step 3. Step 3. In the third step, we can see that in the third step, I am continuing with here. This is the second step product, and in the third step, we can see that you can write this structure here. In the third step, you can see that this pair of electron is coming back. Then what will happen? This OC2H5, this will be eliminated. So what we get? We get a structure like this: CH3, C double bond O, or CH2, C double bond O, C2H5 plus what is forming C2H5O minus. Actually here we are getting our product, ethyl acetoacetate, This is our product. This is our active methylene compound, ethyl acetoacetate. This is ethyl acetoacetate. But actually the reaction, this is not the final step of the reaction. Here you are getting ethyl acetoacetate and ethoxide ion. Here also ethoxide ion is forming. Therefore the reaction is not stopping here. We are continuing step 4. Now next is step 4. So look at it here. This is the step 3 is like this. We get ethyl acetoacetate and sodium ethoxide ion. And in the next step, what is happening? Step 4. What is happening? Look at it here. This CH2 group. Now I am again coming back to our first point. This CH2 group is between two electron withdrawing groups. Therefore, this is active methylene compound. These hydrogen atoms are highly acidic in nature. Therefore, what will happen? This hydrogen atom CH2 can be written as CH. Since these hydrogen atoms are highly acidic in nature, our ethoxide ion formed. Okay. The next step, what is happening in the fourth step? That ethoxide ion C2H5O minus formed in the third step will remove this acidic proton. And what will happen? This bond is shifting to this carbon. This bond is shifting to this carbon, and what we get? We get a structure like this. Okay, shifting to that carbon, we get a structure like this. That again we are getting enolate. This bond is moving to this carbon, so you are getting ion like this: CH3, C double bond O. Here it is CH and a pair of electron and a negative charge, and here it is C double bond O C2. H5. This is enolate ion. This is again, what is that? Enolate ion. This enolate ion can also be stabilized by resonance. What is the resonance stabilization of enolate ion? Look at it here. Resonance stabilization of enolate ion. This pair of electron can be shifted to here. Then what will happen? This will be shifted to this oxygen. So you are getting one resonance stabilized structure. What is that? CH3, C O minus, double bond CH, single bond C, double bond O, C2H5. Okay. So when you are getting this structure, when this pair of electron is shifting to here, then here it will become a double bond, and this bond is shifting to oxygen. So you are getting another possibility. What is another resonance stabilized structure? Look at it here. This pair of electron can be shifted to here, and what will happen? This bond is shifting to this oxygen. So you are getting another resonance stabilized structure like this. What is that? CH3, C double bond O, CH. Here is double bond C, and here it will become O minus and O C2H5. These are the resonance stabilized structure of enolate ion. Okay, this is what is happening in the fourth step. And in the final step, step 5, this enolate ion look at here, this is our enolate ion, this is the resonance stabilized structure of enolate ion. Now this one, protonation of step 5, protonation of enolate ion by an acid. As I told you, the last one is acidic hydrolysis, H3O plus I have written. So last step, what is happening? This enolate ion, CH3, C double bond O, CH, it's a pair of electron, and C double bond O, OC2H5 is protonated by our acid H plus. Protonated by acid H plus, that means this H plus is attacking on this negatively charged this carbon, and we get back our ethyl acetoacetate. And what we get? We get CH3, C double bond O, CH2, C double bond O, C2H5. That means this is taking this negatively charged, will take this H plus 2 here, so it will become H2. So what is this one? Ethyl acetoacetate. Okay. This entire mechanism is known as a Claisen condensation. Very important rearrangement reaction, Claisen condensation. Okay, that's all about active methylene compounds. Thank you.